In this module, we're going to turn our attention to text analysis. As always, these notebooks are in your GitHub repositories, so don't just watch. You need to follow along actively, experiment with the code, try different things, and work with me as you watch this lecture. So text is often found in PDFs. PDFs are great to look at on a screen. That's what they're designed for. They're much more of a pain if you want to extract the text from a PDF into Python or into just a simple text document. So this lecture, we're going to focus on how we can get text out of PDFs. And this is an example of the general rule. Again, the most difficult part of data science is often the data pre-processing and data wrangling. That's going to be 80–90% of your work in a data science project. So in this lecture, we're going to look at how to load in data from PDFs, and we're also going to show how to clean and simplify this text data using the regex library. So before we process any text, how can we get that text into Python? Again, typically plans, policy documents, other sources of text come in PDF format, which is a pain to read. Now there's lots of PDF readers and parsers for Python. They're all flawed. They're all flawed in different ways. So in general, you need to just experiment for your particular PDF until you find one that works reasonably well. There's some discussions at these links which I posted in the notebook, different Stack Overflow sites, which give you a sense of where you can find some good sources. In this lecture, we're going to use pdfminer 6, which is pretty robust and easier to install and use than many alternatives, but your mileage may vary. We're going to start with an adaptation of the Los Angeles Times analysis of California high-speed rail. They have a nice GitHub library where they show how they did their analysis, which they published in the New York Times. And so you can look at their notebooks and their other analyses. If you look at their code, they use the URL library to download files. You can do the same with a couple of extra steps if you prefer to use requests. But for now, we're just going to work with one of their files, the EIR section on air quality and climate change for Bakersfield to Palmdale. And I put this in your Git repository just to make things simpler. Now, the simplest part of pdfminer 6 is the extract text function. Notice that you'll often have to experiment. PyPDF2 is another commonly used PDF reader if you get unintelligible results from pdfminer 6. So let's import the PDF miner. Let's store our file name in this fn variable, and let's just apply the extract text function to this file name, and let's store it in an EIR text variable. Let's see how long it is, just the length of the string that we're going to get. Takes a little while to parse any PDF, so we get 465,000 odd characters. Okay, so we got something. Well, let's look at a few random extracts. So we read the file into a string, EIR text, so we can just use our standard string slicing notation to look at some extracts. Okay, so it's there. There's quite a lot of formatting and stuff, but it looks reasonable, right? So we have a bunch of text that's in our string. But the formatting is something that does need to be cleaned up. In particular, there's lots of these random line breaks that we might want to get rid of. So we're going to use the regex library to convert all of the white space. So what's white space? It's spaces, it's tabs, or the /t, it's new lines, /n or /rn, to a single space. Now, regex is a really powerful pattern matching tool for text. It's short for regular expression. And you can think of regex as a really souped up version of the replace function, which we've already used in many strings. It's not very friendly to use, but there's thousands and thousands of examples online. And here's one good place to start if you want to explore regular expressions. Another website helps you test and debug your expressions, so I recommend these as you're trying to develop your own expressions. Well, let's look at one example. So what does r/s+ mean? Well, the R tells Python that what is following is what's called a raw string. So basically it interprets everything in these string quotes literally, including the slash, which is normally an escape character. Now /s, this is going to match white space. So these spaces, these tabs, these new lines. And the plus means that it's going to match multiple occurrences. So basically this regex string or expression is going to match any white space, however long it is, whether it's 50 spaces or 50 spaces followed by 50 new lines. And then we're going to use the re sub function to replace the white space it finds with something else. So let's import our regex library. So we're going to sub. What are we going to sub? We're going to sub all white space. What are we going to replace it with? We're going to replace it with a single string. What are we going to apply this to? Well, this random string that I just typed in here. As we can see that this tab, all these extra spaces, these new lines, are replaced with a single space. Looks much cleaner. I'll leave as an exercise for you what happens if you omit this plus sign. See what happens and try and explain it to yourself. Well, if we omit the plus and just specify rs, we don't match multiple occurrences. So 4 spaces are going to be replaced with 4 spaces rather than with a single space. But the tabs and new lines are still going to be converted to spaces. So this tab is going to be replaced by a space, but the space is going to be replaced by a space, and this space here is going to be replaced by a space. So we end up with these large gaps between words, and I'm not going to pass judgment on which of these claims is actually more accurate. So now we know how to use regex. Let's apply it to the text that we pulled out of the EAR. So let's apply our matching string. We're going to match all white space, however long. We're going to replace it with a single space. What are we going to apply it to? To our EIR text string, and we'll put it back in the same variable. Okay, so this looks much more manageable. Let's look at another part of the EIR. Okay, this looks much better. The more advanced use of regex is to get rid of punctuation and special characters and digits and so on. So what are we going to do here? Well, the square brackets mean match anything within the brackets. This caret means not, so it's a negation operator. A to Z means any letter in any case. Notice we have an uppercase A through a lowercase z. And then /s is any white space, which in this case is just spaces because we can already converted all our other white space, like tabs. We already converted them to spaces just a moment ago. So this is going to capture anything that is a letter or a space, but actually anything that is not a letter or white space. And it's in these brackets, so it's matching anything within these brackets. So we might want to go back to our old version of the EIR text at a later date, so let's assign it to a new variable rather than overriding EIR text. Let's put it in words only. So what are we matching? We're matching this. What are we replacing it with? We're replacing it with nothing. Okay, so it looks like we got rid of the punctuation, we got rid of the numbers, and so on, which can be useful if we're doing some natural language processing. Well, now that removing some digits means we have some extra spaces. We can see it here, for example, table 3.3 and so on. We replacing these numbers with extra spaces. So let's go back and just apply the same pattern matching as we did before. Replace multiple occurrences of white space with a single space, and now we get a much more cleaned up. Notice that the regex above also is removing numbers. Now I want you to pause the video here and see if you can adapt this string, this command that we used, or this pattern that we used here. See if you can match it so it retains the digits that are 0 through 9. And if you want a hint, look at the websites that are linked above on regex that we just looked at for tips on the syntax. Well, I hope you figured this out, that 0 to 9 represents any number. So we can just add 0 to 9 to our list of characters that are going to be matched. And let's look at this again. Okay, so now we keep the numbers. Sometimes we might want this, sometimes we might not want the numbers. So this looks better. We now have some clean text to analyze. So let's pause here. And we're going to save the text to a file so that we can load it back in at the start of the next lecture. Notice that open opens this file here that I'm just putting in a Scratch folder in our repository. The W flag means we open it for writing. Reading is the default. The with syntax helps because it automatically closes this file object after we get out of this indentation. What am I going to do with this file object? Well, I'm going to write the contents of the string so it's ready for us to use in the next lecture. And you should see this file appear in your Scratch folder. So the takeaways. PDFs are really difficult to work with. pdfminer is a good start, but make sure to look at your output and maybe see if other PDF reader packages are a better alternative. Regex is a powerful tool to clean up your text once you've got the text into Python. It can remove white space, it can remove punctuation, and it can do many other complex search and replace operations. So now we figured out how to prepare our text. Let's leave it there. We'll come back to do some more detailed analysis in bags of words in the next lecture.